So we're in geometry. There were a couple questions that you guys asked at the end of the hour that I didn't get to address with some of you. So let me look at those first. All right, if you have the triangle in a coordinate plane, right, just to kind of get an idea, a rough sketch here, right, if we have the coordinate plane, P is at 0 and 6, so that's on the y-axis. There's P. Then Q is at 8 and 12, so it's going to be up here somewhere. And then 3 and -3, so this one's down here, this is Q there, and this is R. If I want to find the perimeter, I've got to find the distance between these 2 points, the distance between these 2 points, and the distance between these 2 points, and add them all up, right? Now, if I want to find the distance between P and Q, I'm going to use the distance formula. Remember, the distance formula is basically just the Pythagorean theorem solved. So I could find this length, and that's what I'm doing here. So the distance from P to Q is the square root of, now I want to find this distance here, so I'm going to look at the difference of the x values. So from 8 to 0, right? 8 minus 0, so that distance is 8, plus, and then the difference of the y values, 12 minus 6, right? And then I'm going to square that. So 8 minus 0 is 8 squared, 12 minus 6 is 6 squared. Add those together, 64 plus 36, and then find the square root of that. That's 100. Oh, where we go? Here. That's 100, and the square root of that is 10. So PQ is 10. So this right here is 10. Alright, so now I want to find the other 2 points, either P to R or Q to R. Doesn't matter which one we do first. So I can go from this one. Now, remember, I can also use my super trick here. 0, 6, and 3, and -3. And just look at these, say from 3 to 0. That's a distance of 3. From 6 and -3. That's a distance of 9. So I can do 3 squared plus 9 squared, and then I can square root that. That comes out to be 3 radical 10, but we're talking about distances here, so 3 radical 10 isn't going to be of much use, so I need to change that to a decimal. And then I can do the same trick here. Q, 12 to -3, that's 15. So I'll do 15 squared. 8 to 3, that's 5. That's the change in the x's, doesn't really matter which way around. And so the distance from Q to R, QR, is 5 squared plus 15 squared, which comes out to be about 15.81. Add these 3 together and you get approximately 35.3. Alright, here we're looking at this model and we say VSR, this angle right here is 8x plus 18, and we want these to be at a right angle, which means this is 90, so that equals 90. Subtract 18 from each side, and you get 8x is equal to 72. Divide by 8, and x equals 9. There you go. Alright, he wants to ship 24 small packages. They are each in the shape of a cube. Important information, and they're each 8 cubic inches. So we've got a cube, and that cube measures 8 cubic inches. Well, to find one side of this, I would do the cube root. Cube root of that is 2. So one of these sides is 2. So the cubes are 2 by 2 cubes, which means if I have a top that is 4 wide, I can fit 2 cubes in the top, okay, lengthwise. And then across, if this is 9, then I can fit 4 this way, right, and I have an inch extra. So that gives me 8 this way. So 8, I need 8 times 3, right, to get 24. If they're each 2 in length, then that gives me here a side of 6. And that way all of these fit in here. There's a little bit of space at the end. All right. There we go. Ladies and gentlemen, study, study. Make sure you come prepared. Good luck. You got this.